Okay, in this video we're covering functions, and for those of you who are going on to a STEM track, science, technology, engineering, or math, you're going to need to go on in your math career to 1010 after this one. Functions are not going to go away, okay? So use this video to learn them, and if you get confused about anything, be certain you ask questions, okay? Ask them now so that when you get into a harder math class, it makes sense. First of all, some definitions, okay? A function is a relation that maps each element in the domain to only one element in the range. Blah, that didn't make any sense whatsoever, did it? Okay, let me explain each one of these things. Okay, so first of all, a relation is a set of points. Okay, we've worked with sets. We have worked with elements. Okay, but it's a set of specifically points. Okay, there's an example. This particular set has 3 points. Try it again, 4 points in it. Okay, it's a relation. It relates x to y, and in this particular way. Okay, for this particular relation, this set, the elements are points because you have this and then a comma, and then this and a comma, this and a comma. So each of these are points. So that set is made up of elements which are points, and that's what makes it a relation. Okay, now a function is a particular type of relation. So if this circle represents all relations, functions, right up here, functions represent the part of relations, it might be bigger than that, I don't know, that are specifically relations that every element in the domain has one element in the range. Okay? There are other types of relations around here that are not functions, and you'll get into some of those later. But we are going to talk specifically about functions because those are more important for what we're doing than relations are. Okay, so we're going to take this little wedge and break it down a little bit more. Okay, clean that up a little bit. Here we go. So a domain is the input value. Okay, what that means is also the x values of every point. Okay, so in other words, the 0, the 3, -1, and the -4 are all considered the domain values. If I were to write the domain of this relation, I would write 0, 3, -1, -4. Okay, those are not points because the relation is made up of points. Each point is made up of an x and a y value. The x values are the domain values. So the domain is only the x values of every point. Okay, now let's look at the range. You probably figured this out already, but the range is the y values in each of those points. Okay, so 1, -2, 3, and 0. Okay, now notice I'm just writing these in the order that they occur in the points. However, you could put them in any order, and most of the time you will see these in numerical order. Okay, so they would start in this case with -4, -1, 0, 3. Personally, I don't care. I don't know what Canvas will ask though, so be ready to read the directions and see what they ask. Okay, so domain is input. range is output, domain is X values, range is Y values. You have to keep those straight, okay? The easiest way to remember that is that every pair of those things are alphabetical, okay? Domain and range. D comes first. Input, output. I comes first. X value, Y value. X comes first. Okay, I don't know if you want to remember, I know this is weird, but Dix Roy. That's what some students, whatever it takes. I know that they're alphabetical. Okay, so your point values, for example, I'm going to look right here at 0, 1. Point values, this is your X. Try it again. This is your X, this is your Y. This is your input, this is your output. This is your domain value, this is your range value. Each pair are in order. Okay? Okay, so now that we kind of hopefully understand what domain and range are, let's go back to function. A function is a relation that maps or helps you put on a graph. You map 0 to 1. You map 3 to -2, etc. Okay? That maps each element in the domain to only one element in the range. Okay, this thing, let me explain what it is. This is a function box. Imagine that it's a little machine. Okay, I'm going to take a number and I'm going to drop it in the top. And it goes in, does its little thing, whatever it is, and it spits something out. If it spits out one number, then it's considered to be a function. That box functioned correctly because one in, one out. Okay? One in, one out. That's what you want to have happen. Okay? If this little mess in here happens differently, and when it comes in and does its little thing, whatever it does, and it spits out two different numbers, then the box crashes. It's no longer a function. Okay? So one in, one out has to happen in order for it to be a function. And that's what this definition is saying up at the top. Each element in the domain, okay, so 0, 3, -1, 4, maps to only one element in the range. So this goes to this, this goes to this, this goes to this, this goes to this. When I dropped in a 0, it did its little thing and popped out a 1. That's what this tells me right there, right there. Actually, this won't always happen, so let's not use that. Sometimes I'll show you, but it won't always happen. This will. Okay, so I drop in a 0, out comes a 1. In goes a 3, out comes a -2. Put in a -1, and you will receive or get out a 3. Okay, put in a -4, and you'll get a 0. This is a function. Okay, now let's look at something that isn't. Okay, let me explain what this is compared to what we just saw. Okay, domain is the input. Okay, this is your oops, sorry. Let me fix that and lock it in place. There we go. Okay, this is your domain value. And the reason I know that is because the arrows are going that way. So this one becomes this. Okay, so this is your range. So basically we have our little box. Okay, there's the top, here's where they come out, right? If I put an A in the box, I drop it in, okay, what's going to come out? A 1 and a 2, right? So out comes a 1 as well as a 2. This means this is not a function. Okay? So this right here, where your arrow splits off from the domain to the range, means it is not a function. Okay? All of these words may seem weird, but once you hear them long enough, they're going to make more sense. Okay? I'm showing you what to look for, but I'm using the correct words. There are other words that you can use. This could be your X's. This could be your Y's. Let me erase our little box. This could be your input. This could be the output. Any of those words on that first page of definitions. You could just say in and out. It doesn't matter. Okay? But the first column, the domain, the X's, the input, these numbers can only have one value that they point to. So this is a problem right here. B points to 3, and that's it. C points to 4, that's it. But A points to 2 numbers. That's the problem right there. Okay? This is your problem. Okay? And under my green box, this is what it says. Okay? You probably already saw it on your notes, but I didn't want you to get too distracted on the video. So first of all of these, A, B, and C, are your domain. 1, 2, 3, and 4 are your range. It is not a function because A is being mapped to 2 different values. A points to 2 different values. There are 2 different values connected to A. There are so many different ways of saying it, but mapping is the mathematical term, believe it or not. Okay, let's look at another one. And you're probably already looking at your notes, but try not to. Okay, is example 2 a function? A maps to 1, B maps to 2, C maps to 3, D maps to 4, E also maps to 4. So the question is right here. Now remember, our definition of function is 1 in, 1 out, right? Does this happen? There is one D and it points to one answer. There is one E and it points to one answer. They can point to the same one. It doesn't matter, as long as there are not 2 arrows coming off of any one of these original values. For example, E could have gone all the way up here and not there. It would have been fine still. Those arrows don't have to look nice and parallel and even and all that. Okay? If D went to 3 and 4, that would be a problem. But because each one of these has one arrow coming off of it, it is a function. Okay? And you can see that from what it says. Okay? It is okay that D and E are both being mapped to 4. They have one arrow leaving them. And it's only a problem when an element of the domain has 2 arrows or more leaving it. So this one is a function. Yes. Here's a different way of looking at it. Okay? This is a set of points like I showed you at the beginning. So the first thing is, what is the domain? If you remember, absolute, or try to get alphabetical order, these are your X's, these are your Y's. So all of your X's, the first term in each, are listed here. And they are in order of the points, but they also happen to be in numerical order. Okay? Your Y values are your domain, which it says right here. And you can see the range values are right here. Okay? So domain is first, range is second. Domain, range. Okay? Is this a function? This is harder to tell. What you need to do is see if, in the definition, each x value maps to only one y value. Okay, I'm going to back up to that screen that is not a function. Okay, if we were to write this as points, let's just pretend that a, b, and c are variables, and it looks like this. Okay, that is what it would look like as points if a, b, and c were numbers, right? Okay, looking at just the points, this pink circled part is represented right here. Okay, because that's your a values. Whoops, sorry about that. So when you have a in your x position twice with two separate numbers after it is where the problem happens. Okay, so if I put a into my function box, 1 would come out. But if I put a in my function box, 2 comes out. So the fact that two different numbers come out makes it an issue. That's telling us that two arrows are coming off of it. So that means right here, okay, what you're looking for is to see if the x values ever repeat. If they repeat with a different y value, then it won't be a function. Okay, so look for repeating x values. Repeating x's with different y's means it's not a function. Okay, this one has no repeating x values, so it's a function. Okay, okay, this one. First of all, we write the domain and we write the range. So you take all your x values, 2, 1, 1, 3, 5. Remember, you do not duplicate elements. You just write it once. If it occurs twice, you only write it once. Okay, a range value here is 1, 2, 5, 1, 0. So we're only going to write the 1 once, but then there's the 2, 5, and the 0. So we have some repeats happening. So you can't look to see, it's like, oh, this has more than this, or this has less than this. It doesn't matter. Okay? It's not a function, however, because we have repeating x values right there. 1, 1. Okay, so 1 goes to 2 and it goes to 5. That's not good. Okay, which means, okay, I keep moving the page around for you, sorry. If I had a graph like this, 1, 3, 5, these are my domain values, and I'm going to point arrows to what they map to. -2 maps to 1, 1 maps to 2 and to 5. 3 also maps to 1, and 5 maps to 0. Okay, so the problem is right here because 2 has 2 arrows, or 1 has 2 arrows coming off of it. This 3 that also points to the 1 isn't an issue. It's the 1 because it has 2. Okay, not a function. Okay, here there are 3 different ways of looking at it, and we haven't really looked at the second one, this T-chart. Let me tell you what this is, and then I'll let you figure it out. Okay, each row represents a point. So this is point -3, 4. And sorry, my writing's so big. And this is -2, 4. And this is -1, 4, and so forth. Okay, so go ahead and pause, try these 3, and come back. Okay, here goes number 1. Domain is the x values. It's the input. Okay, so that means these, right? The domain. the ones that you start, see if I can spell, the ones you start your arrow at, okay? Technically, it should be in a set. If you don't write it as a set, I will put the set in for you and probably let it go, but just know that it should be a set, okay? Your range is where the arrows end. So this is your x values or your output. Okay, so that is just putting those in order as well. -6, -1, 0, and 5. Okay, looking at this part doesn't really help because we don't know which one maps to where. Okay, we have to look over here. And is it a function? No, because of right there. It has 2 arrows coming off of it. The 0 doesn't matter. It doesn't matter that there's 2 coming to 0. It matters that there are 2 going away from 1. So it's a no. Okay, this one. What's the domain? I can't remember what color I did. Teal first. Okay, so the domain are all of your x values. So -3, -2, -1, 2, and 3. Your y values are your range, and there's only 1. Okay, so is it a function? Yes or no? It is a function because none of the x's duplicated. Okay, since none of them are the same, it's okay. They can point to the same value, but they can't have 2 coming off of them. Basically, that's what it looks like. Okay, every single one of the x's has 1 arrow. Okay, bottom one, set of points. Is this a function? Let's find out. So first of all, the domain is all of the x values. So 9, 8, 7, and 6 in order. The range, just in the order that the points are given. I don't care that they're out of numerical order or not. -9, +8, +6, -9. So technically, we don't need that one, right? If you write it twice, it's not wrong, but it's not used. I don't know if that makes any sense, okay? Just don't do it, but it isn't wrong, okay? Is this a function? Are there any duplicate x values? Nope. So yes, it is. Okay, there are other ways of looking at functions, and we'll go over some of them later, but for right now, hopefully these make sense. Let's go on to evaluating, okay? We have done stuff like this before, okay? We have an expression, and we just need to put the value for x in for x and see what we have, okay? So they put the 3 in for the x, and we got 2 times 3, and then subtracted 4. Order of operations, we're doing multiply first, and we got y equals 2. Okay, so we evaluated this expression for when x equals 3, and we got y equals 2. Okay, this other side looks really kind of funky, doesn't it? It means exactly the same thing. Well, I got a lot of extra space there, sorry. I was trying to get to the end of the box over here, and there wasn't one. Okay, so this and this mean this exactly. Okay, this part right here, f parentheses x, you read it as f of x. This is not multiply. This is not f times x. This is f of x. If you see something written in this format, that's always what it means when we're talking about functions. Okay, so this is saying that we have a function named f, and it's using x as its variable. And this is what it's equal to. When it has this, f of 3, it wants you to evaluate the function at x equals 3. Okay, you notice f of x, the x was changed to a 3. So we want to know what it is when x is 3. Basically, that function box we had at the beginning, I'm going to drop a 3 in it and see what I get. Okay, to do that, you write f of 3 is equal to 2 times x, but now x is 3, minus 4. Order of operations, same process, and you get 2. Okay, when you have a function notation, you know that it's a point. You have input is x, output is y. It is a point on a graph. Okay, so this representation right there, the x is the 3, and the answer that you got is the y. Input, output, domain, range. Okay? Okay, 2 for you to try. If all of this stuff seems to have made sense, go ahead and try it. You're looking for 2 values for f and 1 value for g. This is still a function because it's written in this same format. If you have more than one function, you can't call them both f because then the people would get confused. So you can use different letters here. They generally stick around the alphabet around f, so they use F, G, H, and K the most, but you can use anything. Okay, so find f of 2, f of negative 2, and then for this problem, you're only finding g of 1. Okay, if you're still kind of lost, then don't pause it. Let's just do them together. All right, this first one, f of 2. What I'm going to do is I'm going to figure it out this way. Everywhere I see an x, I'm going to leave an open parenthesis, set of parentheses, there you go, and I'm going to put a 2 in them. I should have left that first one blank too, because x is now 2, x is now 2, x is now 2, according to this. Now we do order of operations over here to see what we get. Okay, order of operations is parentheses first. In these parentheses, there's nothing to do. So we don't count these as parenthesis operation. We count them as just, oh, this is a 2. So that doesn't count. Exponents are next. So we're going to do this part right there. Okay, so 4 times 2 squared is 4 plus, and I'm going to change this to a dot because I did that over here. So now 16 plus 16 minus 6, you do multiply before add and subtract, right? And now add and subtract from left to right. We get 32 minus 6 is 26. Okay, so what you basically just found, 2 is your input, 26 is your output. So you found the point 226 on a graph. That's not what they're asking you for, though. They're asking you to find f of 2. We already did that. F of 2 is, whoops, f of 2 is 26. Okay, now let's do f of negative 2. So I'm going to write the original function, but leaving the x's blank. And I'm going to fill in those with the value that they tell us. -2 this time. So -2, -2, -2. Now remember, this is not f times -2. This is function of 2. What is the value of the function f when x equals -2? Okay, so let's continue finding it. So again, exponents first. So I'm going to do 4 times -2 squared is +4. Two negatives give you another negative. Now over here, I'm going to leave the parentheses because it's a negative. If I didn't, it would look like this, and what is this? Is that a multiplier or subtract? You know, it gets confusing. So here we go. Now we're going to do the multiply. 4 times 4 is 16. 8 times -2 is -16. Bring down, subtract 6. 16 minus 16 is 0, minus 6 is -6. And we're done. Okay, so this is your answer that they're looking for. Okay, so down here at the bottom, g of x. Like I said before, g is just a function. It's just different than f, so they had to call it something different. You can have multiple f's. That's not an issue. This could have been called f of x instead. They're just trying to give you some options of what you will see by changing the letter. Okay? All right, so I need g of 1. So that's what I'm going to do. I'm going to replace all of the x's with 1s. And for me, it's easy to do it by leaving blanks because I'm changing colors. If you can do it as you go, do it. That's fine. I'm putting 1s in here. Okay, next. Let's figure out what we have over here on the right. Oops, dropped my pen. Parentheses for PEMDAS, right? Parentheses, exponents, multiply, divide, add, subtract. Parentheses also means any kind of grouping symbol. So parentheses, brackets, division bar, absolute values, square roots, anything that groups things together. So because this is grouped together, that's what we need to do first. Okay, so we need to do that before I can do anything with the 4s. So times by, inside the absolute values, we're going to multiply first. So 6 times -1 is -6. Add 1. Still doing inside the absolute values, so the 4s need to wait. -6 add 1 is -5. Now we can figure out the absolute value. Absolute value of -5 is +5. Next we do multiply before add, right? So -4 add 20 equals 16. There we go. Okay. Okay. This part looks crazy. It's not really bad. Let me explain. Okay, the domain of a rational function, in other words, fractions. If there is a variable in the denominator, you could have an issue. Okay? Okay, it's a problem if the denominator ends up being a 0. Okay, so for example, here's your function, f of x, and if you find f of 11, they've gone through it, done all the math, and the answer is -35. So you found the point 11, -35 on a graph. It worked. You got a point. Okay, but over here, they tried -6, put it in, blah, 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 blah. You can't divide by 0. So you don't get a value. So what that says is when you put -6 into the box, you don't get anything out. This does not provide you with a point on the graph. It is undefined, so it becomes a problem. Okay, so if you get an undefined answer, it doesn't provide a value for the y part of a point. You won't get this. Okay, so your domain values, your x values, can only be the numbers that give you an answer. So x cannot equal -6. It can equal anything else but -6. And the way you get that is by looking right here, because there's a variable in the denominator. Okay? Now, how do we figure that out from the denominator? The way you do that, and it's not on this page in your notes, I apologize, you take this part, just the denominator. The top doesn't matter at all. There can be variables anywhere on the top, and it doesn't matter. However, the bottom is where it causes a possible problem. So you take the bottom and set it equal to 0, because that's what will happen here. It's the 0 in the denominator that was the issue that made it undefined. So we're going to set the denominator equal to 0 and see what value we get. So now we're going to subtract 6 from both sides of this equation, and we get x equals -6. So if x equals -6, that's how they got this. If x equals -6, because that makes the denominator 0, I won't get a point on the graph. So this needs to be an exception. Okay, so it's all real numbers except -6. Okay, and on the next page, I'll show you how to write that. Okay, here we have a new function, g of x. It's nowhere near as complicated. Why didn't they start with this one, right? Okay, you check to see, because it's a fraction, if there is a variable in the denominator. And there is, right? If there is a variable in the denominator, you take the denominator and set it equal to 0, because if the denominator is 0, that's where the issue happens. So you set it equal to 0, solve it. So if x is 4, then we get 4 minus 4, which is 0, and that is undefined. Okay, if you get an undefined answer, it means you don't have a value for y, and you don't have a point, which means we need to say that doesn't exist. It's an exception. Okay, so it cannot equal 4. 4 is your exception. So this one right here is how you say x cannot equal 4. If you want to, when you're solving the equation part over here, you could write not equal to and solve it. Okay, and I'll do a couple that way so you can see it. It doesn't change the problem, it just puts the symbol in there for you. Okay, so this answer right here means the set of all x's such that x doesn't equal 4. So you can have any x you want, all x's, as long as x doesn't equal 4. So it's everything but 4 is what it's saying. Okay, so yep, B is your answer. Okay, here's your turn. So see what you can do with it, pause it, and come back. Okay, on H, we're going to look at the denominator because there's a variable there. So we're going to say x plus 5 doesn't equal 0 will be the value that we're looking for, right? So x plus 5 cannot equal 0. If it does, it needs to be an exception. So now I'm going to solve this. So here's the center. It's just going to be a different symbol. And we're going to subtract 5 from both sides. So now we get x cannot equal negative 5. It can be anything else. It just cannot be negative 5. So that's this one right here. These two things we'll get into in another chapter, but they're throwing them in now just because it kind of fits. Okay, number 7. We are looking at the denominator because there's a variable in it. The top could be anything. All we care about is the bottom. So we're going to say 2x minus 1 equals 0 because that's where the problem happens. And now let's solve it. So we're going to add 1 to both sides, and we get 2x equals 1. Divide both sides by 2, and we get x equals 1 half. So 1 half is the value that we cannot have in the domain. Okay? This answered the question, what value is not in the domain for f? X equals 1 half. It didn't say to write it this way. This describes the domain. This is the set that is the domain. Okay? If I were to write number 7 that way, I would have written all x values such that x cannot equal or does not equal 2. 1 half. There you go. Okay? But the pink part answered the question. What value is not in the domain? 1 half. Because if x was 1 half, and I put it in here, okay, I'm going to put 1 half in for x. 2 times 1 half is 1. 1 minus 1 is 0. If this is 0, it's undefined. You can never divide by 0. Okay? And that's it for this section. So that was a lot, and this is probably new for almost every one of you. So do your best, ask questions in class, and you got this.